This slide shows the summaries of the topics that we have discussed in these chapters of Integrations 2. First, you are introduced with a list of the equations for the standard integral, which normally appear in the form of single term. You may refer to the list of the formulas given for you to make direct integrations based on the factors. There will be a constant c after the integrations. This list of formulas is useful for you to do integrations and save your time through the tedious work, and it is applicable for common integrals. Next, you are introduced with the concept of integrations with limit. There will be boundary conditions, where the bottom will indicate the starting of the boundary conditions, while at the top of the symbol of integrations, it will be the ending of the boundary limits. You will integrate these functions as normal, except the integrated functions will have to indicate with the respective boundary conditions. Next, you have to substitute the boundary conditions into the functions, minus the substitutions of the upper boundary with the substitutions of the lower boundary. Solve the respective functions, you will get the final solutions. If the functions appear in the form of multiplications, you may use the product rules formulas. It is in the form of u dv equals to uv minus integrations of v du. This function is actually derived from the product rules of the differentiation functions. When you encounter this kind of questions, you need to set one of the product function as a u, while the rest will be the dv. From the identified u functions, you had to determine the du, and from the dv functions, you had to integrate in order to get the respective v. Use these formulas to substitute the u, v, and du into the functions, and you will need to integrate the v du. With that, you are able to solve the questions. Next, you are also introduced with the partial fractions. Integrating the partial fractions questions normally happens when there is a fractions and it constitutes of various components of the functions which make the functions to be complex. However, you are able to factorize the domains of the fractions, and with that, you can use the principles of partial fractions to expand it. Taking these examples, after expansions, there will be 3 single terms. This makes the integrations process to be easier. Lastly, you are introduced with the trigonometric functions, which you need to integrate. This may be the most challenging questions that you might going to encounter in these chapters. The reason is you might need to do several times or try and error in order to acquire the best method to solve it. These are some tips for you to solve the integrations with the trigonometric functions. Always check for the equation list. There will be a list of the equations being used for the conversions of trigonometric functions. At the same time, you have to cross-check the list of the equations for the standard integral. Second, you need to reduce the powers to become power of 1 for the trigonometric functions. If the cos sign is in the power of 2, you will need to use the equations or trigonometric functions to reduce to 1. If the power is odd number in the form of 4, you will have to reduce the power to 2 and then later reduce to 1. This is again done with the list of the trigonometry functions, and it involves a lot of expansions of the functions. In the case that you encounter the power which is in the form of odd number, you will have to take out the one of the sine or cos out of the numbers. That leaves the cos and sine with the power in the form of even number. Then you may use these equations to solve the integration functions.